Hello and welcome friend. In this tutorial we will try to look at some of the if conditions with respect to finding if a file is a block device, character device, is it a regular file or if it exists. So there are different ways you can do that and I will show you one of the ways. So if you see here the syntax is like this. If you say "-p" and then followed by a file name and it will return you true if it's a block file. So B is for block file. Then similarly there is a character file C, and then D is for directory. We have already gone through directory, and block file and character file I will cover very shortly in this tutorial. Then E is for file exist. When we say file exist, then it means just its existence, whether it's a block file. So "-e" will return true for a block file or a character file as well. So and "-e" will return true for directory as well. So if you say "-e", that means it just exists. It doesn't give you a granularity whether it's a block file, directory file, or if it's a regular file. "-f" is for regular file, or maybe "-r" is for read file. So you can go through all the options by looking at the man test. So let's quickly run through some of the example which I have created for you guys to look into this block file and character file. So we will look for example one. I have this test file test1.sh, and before I go ahead and explain you, I have created some file here. So if you look here, I have created one file which is called sdcd1, and it is B, which is a block device. Then sdcdp1, which is a character file, and I will show you how to create those two. And then it's a regular file messages.log, and if you see here hyphen, which means it's just a regular file. You could create one file with touch 123 or something, and it will be created as a regular file. And then this zebra underscore log is a directory you could create with mkdir. We have already seen those things. Now let me demonstrate this program to you guys. So I have a variable file name, and in this file name I have put the first string as messages, and I check if "-e" file name. So "-e" means the file exists. It doesn't care what kind of file is it. So it will say echo file exist, which is true. It will say like that. And then it's a "-f" file name. So same variable I will use with "-f". "-f" means it's a regular file, and of course my messages.log is a regular file, so it will say $file exist and is a regular file. Now let's suppose if instead of $file name, if I could have used block device file name, then it would have not fall into this category. It would have not said it's a regular file. It would have just come out of this conditions, because this condition would not have been true. And similarly I have reset this file name variable to another variable sdcd1, which is my block device. And if I run through this and say if this is a block device file name, it will say file is a block device name. And then I have similarly done for character device, which is at line number 21. So all these are my line numbers, so don't worry, in the vi editor I have set the line number. So at line 21 it says I set to a character device and check if it's a character device. So actually this should be RC character device, and says it's a character device file. And then lastly I have this zebra underscore log, which is my directory, and if I test with -t, and it will tell you it's a directory. Mind it, even if for a directory, if I test with -e, it will return that it's still a file, because directories are also treated as a file. So let me quickly run this program and see the output. So if you see here, messages.log exist. Of course it exists. So it could have said this existing thing for zebra.log. You could have used any combination, but I'm just using one of them. And then messages.log exist and is a regular file. So if you see here messages.log, it's a regular file. You could create this file with the cat command, touch command, or maybe with a vi editor, or maybe any editor. Then file name is a block device name. So I have not given a dollar, so let's quickly modify this so it could print the right thing. So it should be here dollar, so it should give the variable name correctly, and here dollar and this is also dollar. Okay, so let's run this program once again. So first I will do ls minus l so that I have the listing of all the files and folders and run this. So now if you see here, it says sdcd1 is a block device file. So if you see here sdcd1, it is followed by it is having starting with b, which is a block device file. It's a special file. And then this is a character file sdcdp1. This is a character file c, and then zebralog is a directory which we have seen, zebralog. So this is the way you can test whether a file is present or not. So where exactly you will use this kind of things? Let's suppose you are trying to upgrade from MySQL to MariaDB, and this upgrade will happen only once. Each time you update the system, you might not be doing that. So how do you know whether you have already upgraded from MySQL to MariaDB? So first time when you do upgrade, you might test for a file in some temporary folder or maybe in some predefined location, and if those file doesn't exist, then you can go ahead and do the upgrade. Next time when there is a subsequent upgrade for a new software, you will test for that file. If that file exists, you will not do that. So that file could be regular file, or depending upon the use case, you could have different kind of files. The other block device and character device you could use to test for presence of some device, like if you insert your USB device, that will be treated as a block device. So you can test whether your USB device is inserted or not. What is the kind of device it is present. Now, a quick overview. Even though block device and character device should not be a part of bash shell scripting because it requires some other knowledge with respect to kernel file system, but I will quickly try to guide you guys. In Linux and Unix kind of operating system, everything is a device and everything is a file. So they do all kind of operations treating everything as a file. So if you have a pen drive, and pen drive like a USB stick or maybe a hard drive, they're treated as a block device. So when we say block device, a block device reads from the kernel in terms of blocks, certain number of bytes at a time. It will not read one character at a time. It will read maybe 512 character as a block or 1024 as a block, and it will try to read as many blocks as possible in subsequent chunks. The other advantage of block device is, in block device, when you read the data, you can go back and forth and you can peek into the data. The opposite is character device. If you take mouse and keyboard which are connected to the system, those are treated as a character device. In case of character device, you cannot peek inside the data. Whatever data you have received, you have received. You can receive one character at a time, but you cannot go ahead and peek inside the data. Okay, you cannot go back. What was my last data? You might have to do some kind of a buffering. So block device are faster and character device are slower because it's received character by character. In block device, you can go back and forth in the data. In character device, you cannot. You can just receive serial data one byte at a time. So let's quickly go through how you can create a block device and a character device. So I will demonstrate, and I already have a PPT for that. So this is my PPT. So this is a command called mknode and followed by node name. So you will give any node name. Most of the time the device files are present in /dev folder, but you could give any name anywhere. And then followed by B stands for block device, and then major number and minor number. Major number and minor number are a device identifier, and there has to be a combination of major number and minor number has to be unique. So what it means is that there might be conflict if you assign, like in my example 4,3, but since it's your system and it's no one else might be using it, you can use it. But if you want to allocate major number, minor number, you have to look into kernel documentation, or you might have to allocate dynamically by querying if the device doesn't exist. For me, I know for sure it doesn't exist. Probably it might be okay for you guys also. And then the command, similar command is for character device. The only thing is B is replaced by C, and it means it's a character device. So let's try to quickly go through this example and create this. So I have this sdcdp1, so I could say mk node, and then I could say maybe my node block underscore block. I will just to identify it's a block device, nothing else. And I could say 5 comma 6, so 5 space 6, not comma. And mind it, when you create mk node you need to do sudo. If you are not a root user you have to do sudo, because it requires a special privilege. And if you see here, my block device is created and there is the letter B here. It's not like hyphen, it's a B, block device. And you see for block device there is no size. For regular file you will see the size, the number of bytes it's present in a file. For block device it's a major number and the minor number, same major number minor number which we have given here, 5 comma 6. Now with a similar command let's create a character file, and this is, I will just say char, and you could give anything, 5 comma 7. Now if you see here my char character device here, it's a C, and the device major number minor number is 5 comma C. So this is the way you can create major number and minor number for any character device or block device, and you can create that. For knowing this major number minor number, because now I cannot create another block device with the same 5 comma 6, I might have to have a combination, and I cannot exhaust that combination. So if you look, there are tons of block device and character device in slash dev. So let's quickly go through and I will show you. And if you say ls minus l, you will see there are tons of character device. Your terminal type are also character device, if you can notice. And then if you scroll up, you will have other block devices, lot of devices. You see this is a loopback device which is used for mounting some disk and ISO files. And you see huge page size is a directory, and there is a character device. So you will see a lot of block device and character device. You see lots of block devices here. And there might be dev SDA, which is your hard drive, and there might be secondary disk, dev SDB. Those also might be treated as block device. So this is about block device. Now let's look into the test condition. In the test condition we have checked about the file, block device, regular file. Now what if there is an output from a command and we are taking into a variable and check whether that we receive some commands or not. So there are two things which you can do. One is -n with string, whatever the string you got, and it will return true if the string is non-zero, and -z means if the string is 0. In fact you could have done with just -n to say if it is non-zero then that means it's a 0, something like that, if else conditions. But then there is two test statements which you can use. So let's quickly go through that example. So I have another example, test2, and here I have one string called hi there, which is non-empty, means it has some data, and then other string2, which is blank. Now if I run with -n, the first string, so remember n is true if the length of the string is non-zero. So of course this is non-zero, so it will say the length of the string is non-zero, it will not fall here. Now z means comparison if the string is 0. So if I say z with string 2, which is of course length 0, it will tell me the string length is 0. So if you run this program test2, you see in the first case it says the string of the length is non-zero because it's non-zero, and the second case the string length is 0. Now this we were testing with string 2, which is length 0. Now what if I make this to string 1? So if I say string 1 here, now you see here string 1 is non-zero, so right, so it will fall here, it will not say the length of the string is 0. So you see length of the string is non-zero because string 1 is non-zero. So this is the way you can do comparison with respect to string. And remember, when you are doing string handling, it's always better to do a quote within a double quote, and you put your conditions like this. So there are many other options like -n, -z, and with respect to file also, like we have looked like -b for block device. So if you want to refer to the complete man page, you can say man test, and you will have those kind of test expressions. So you will have, you see I was demonstrating this -z if the length of the string is 0, if the length of the string is non-zero. So you can have all kind of things, minus b if it's a block file, character file. So you can say man test and you can refer to all the manuals. One more example lastly I would like to show before I close this session. Just one example, nothing else. So there is a command called id, and id will give you an identifier. Each user in the system has a unique identifier. There might be same identifier for two different users, but it's generally not recommended, but you can do that. But usually all users will have a unique identifier. Now with identifier, if you run this command id, it will give you certain details like your uid, group id, and groups, which groups you belongs to, blah blah blah. If you just want to do know your id number, there is an option called -u, and it will return you certain integer number. So there is this syntax, and in this syntax I will run if loop, if statement is a conditional statement. And what I do is id -u I will run, which will return 1000 or whatever the number I have, and I will take it as a value. So I will put a dollar, and there is a syntax that if you put it within this bracket, it will evaluate and put it as a comparison statement for the another statement. So it will evaluate and put it as a normal some variable, and you compare with the 0. So in system, 0 is always assigned to the root user. So if this matches 0, and you remember for shell script, equals to is actually like equals to equals to. So for comparison in shell script, the right way to do is equals to, not equals to equals to. In fact, you can do equals to, but that is not POSIX compliant. This is not POSIX compliant. Equals to is a POSIX compliant. So that's the way they made it. So if you are a super user, which means your ID is root 0, so it will say you are super user. Otherwise it will say you are not a super user. This kind of script you will need. Suppose you are running some script and you want to do some system changes. Maybe you are automatically partitioning some disk or finding some free space in some sensitive locations in your disk, or somewhere you don't have permissions. You can run this kind of test to check whether you have the permissions, whether you are a super user or not. You can bail out very early rather than failing at later stage. So you can check, okay, this script needs to run as a super user, so check it. So let's run this script, and if I run this script, it will say, okay, you're not a super user, your ID is 1000. Of course, that is what I'm not. Now if I run this same script with sudo, which means I will become a super user, it will say super user. So when I am super user with sudo or su, if I run su, and if I give my password, and if I run the ID, sorry, I think my super user password is not right here, but anyway, so if I say sudo id, so it will give me root. So that's all for this video, and I hope to see you in the next video. Thank you for watching.